Hello everyone, my name is Debashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is a very important one, that is the OSPF protocol, Open Shortest Path First, and we'll deep dive into it and we will see what is the different features of the OSPF protocol, why it is so unique and why it is so popular in the routing environment. So let's begin. So we'll explore in depth the OSPF, Open Shortest Path First, and this is a link state routing protocol, as you know, and we'll cover its architecture, operations, configuration and advanced features. So what do you mean by this link state routing protocol? Definitely it is a dynamic routing protocol, like you do not need to actually configure the entire path from the source to destination like any other dynamic routing protocol. But link state routing protocol means that every router has the complete routing information, the routing updates about other routers. Every router has got the complete information in its routing table. So in case of the other protocols like distance vector routing protocol, that is not the case. Every router doesn't know about each other. So that is the advantage of OSPF has. Now OSPF is unique because it is a link state routing protocol and it is designed for the efficiency and scalability. Yes, OSPF scales well because in an enterprise network you can have a lot of say network prefixes that you can advertise in the OSPF protocol. It is not like the BGP, but yes, OSPF is also a very big routing protocol. What are the key features? OSPF supports hierarchical routing through areas, fast convergence and efficient use of bandwidth. Means you are having something known as areas in the OSPF to minimize the LSA flooding. So you can have an autonomous system just like the say the EIGRP protocol, and also the autonomous system of the AS is divided into areas to further reduce the LSA flooding. Now fast convergence is a result of that, and efficient use of bandwidth, definitely OSPF is fast, making it suitable for large enterprise networks. Now let's discuss the comparison between OSPF and other routing protocols, say the RIP or the routing information protocol. OSPF definitely differs from protocols like RIP and EIGRP in its method of routing updates. Like I was telling you that RIP doesn't have the complete routing information of other routers, but OSPF has. And EIGRP is a say a hybrid routing protocol or an advanced system vector protocol mainly based on the bandwidth and delay, but it's not as fast as the OSPF. And OSPF, it is very fast and it allows for more complex and scalable network designs than the other protocols. What is the OSPF architecture now? OSPF consists of routers, areas and backbone networks. Like it can have an area, a backbone area, that is the area 0, where the area 0 is controlling every other area. So if you are going to have the multi-area OSPF, say you are having the areas from area 1 to 65535, then if you want to venture from one area to the other area, then definitely area 0 should control that. Area 0 should control that routing update should flow from one area to the other, and the OSPF areas and hierarchy, like OSPF organizes networks into areas to optimize performance that I was talking about, with area 0 as the backbone connecting all other areas, and one interface of a router should belong to the area 0, otherwise the routing update cannot flow. That is very important. Now let's talk about link state advertisements a bit. LSA. LSAs are used by OSPF routers to communicate the state of their links and the network topology information. So it is a multicast information or the multicast routing updates. Why is it multicast? Because it is sent to the other routers using a multicast address, that is 224005. Now in case of OSPF operations, routing table calculation, now OSPF uses the Dijkstra algorithm to compute the shortest path tree. So using the Dijkstra algorithm, it actually say compute the cost for each link, and it constitutes the shortest path tree or the SPT based on the links to database LSDB, and each router maintains its own LSDB and which builds it from the link state advertisement received from the other routers. So the cost is also cumulative. When it is sending the update to the other router, then the cost gets cumulative in each length. Next is the hello protocol. That is also a very important feature. The hello protocol is crucial for establishing and maintaining neighbor relationship, and OSPF routers send hello packets to actually discover other OSPF neighbor routers or directly connected network. Now OSPF hello protocol has some timers. It is dependent on the network type, like the broadcast, non-broadcast, multiple access, point to multi-point, point to point. Now in case of the NBMA, that is non-broadcast multiple access and broadcast network, the hello is actually 10 seconds. In every 10 seconds the routers exchange hello, and the dead timer is 40 seconds. Means if I am the router and I am sending the hello to the R2, then if R2 is not responding, I will send maximum 4 hello packets in say 10-second interval, and after 40 seconds elapsed, I will declare the neighbor as dead. Now in case of database synchronization, it occurs when OSPF routers share the LSDBs with neighbors to ensure consistency, and definitely they share some packets like the LSU or the link state update, and they receive link state acknowledgement. So they compare their LSDB when they are booting up, and then they share the routing updates. Now in case of OSPF configuration, that we will do in a minute in packet tracer. So you have to have an OSPF process ID. Process ID can be unique or it can be same in any OSPF router, because it only identifies the OSPF process that is running on the router, and it defines the networks to be advertised. Now OSPF network types, I was telling you, like it has a point to point, broadcast, non-broadcast, multiple access, different, and definitely it has some slightly different configuration, but mostly it is the same. Troubleshooting steps for OSPF include the checking interface status, like some route is not advertised, route is not being shown in the routing table. So you have to check the interface status whether it is down or up, verifying OSPF neighbor relationship with the show IP OSPF neighbor command, like this. And in case of OSPF advanced features, you are getting the route summarization, where you summarize the routes to actually lower down the CPU overhead in the router, allows for the grouping of multiple routes into a single advertisement, reducing the size of routing table. Also you have OSPF authentication. So it supports authentication like the either the plain text, clear text, or the cryptographic, that is MD5. And OSPF also supports in IPv6, like OSPF v3 is the version adapted for IPv6, and it has some new LSA types as well. So we can conclude that OSPF remains a robust routing protocol, and it is suitable for various network sizes. It can be mid network size or it can be a broad network size also, and its features such as fast convergence and area based design or hierarchical design, it definitely makes it ideal for modern networking. So that is about the theory part behind the OSPF routing protocol, and now I can take you to this simulator, that is the Cisco packet tracer we use, and I will show you how to configure a single area OSPF here. So you take the two routers, that is a PT router or any router you can take, then you connect it with the serial port, then you take the PC, then you connect it with the say cross cable. If you take a switch, then you have to use the straight one. And now let's configure that. Say in the Ethernet, I am giving say 10001, and it is a classless routing protocol, so you can provide other mask like this, like the class B. And in the serial, first is clock rate, then the IP say 192.168.1.1, 55, 255 and 252. Now you configure the OSPF with router OSPF and then give question mark. It will ask for the process ID. It runs from 1 to 65535. Say let's give 1. Then you advertise the directly connected networks. that is say 10,000, and now you will advertise the wildcard mask that is very unique for the OSPF. Now how you get the wildcard mask? You just subtract the subnet mask from the broadcast IP. So in that case it would be 0.0.255.255 and then the area space 0. Also for the network, that is a serial 192.168 then 1.0, and if you subtract 0, 0, 0 and 255 minus 252, that is 3 and area 0. So every interface should be connected to area 0. And then go to router 1. So let's go to the Ethernet port first. Say 20001 and you are giving the same class B mask. Again you go to the serial, you continue giving the IP address, say 192.168.1.2, 255.55.255, then 252, and there you configure OSPF with router OSPF. See, I can give one, the same procedure, or I can give some other, say 2 I am giving. Network, then 20.0.0.0 and 0.0.255.255, then area space 0, and the network 192.168.1.0, 0.0.0.3 and area 0. So right away you should see a message should come from the OSPF, that is this is a procedure, yes. So it is showing you that the neighbor 1.1 is up and the database synchronization is done, that is loading to full loading done. If you go for the show IP route, you will see the all the connected networks as well as the OSPF route, that is 10.0, 110 it is AD value and 65 is the cost that it has calculated. Now if you want to see only the OSPF route, you give show IP route OSPF to filter out only the OSPF route, and you will see only the OSPF route among these routing informations. Also you can verify the show IP OSPF say neighbor. So then it will definitely show you that the neighbor ID is 1.1 and the state is full. So there are some states like full state, like these neighbor states like OSPF neighbors, they actually have the full state among themselves, and they say they establish two-way states to the TR or BDR, that I will cover later someday. So that is about the say the OSPF, say the troubleshooting commands you see like show IP OSPF. Say you can say the database, interface, neighbors. So say database, you can see in the database it is showing you the type 1 LSAs here. When it is showing you the link IDs 1.2 and 1.1, that is a two router IDs is showing you, and it is a type 1 LSA. Means every router advertises its own IP address, its own router ID as the type 1 LSA. It's advertising itself. So here you have all the informations of the LSA types, and OSPF has a router ID concept that you can give the router ID, but it is optional in the IPv4, because in IPv4 supported OSPF the router ID is taken from either the logical interface, the highest logical interface, or the say the highest serial interface IP. But in OSPF v3, in OSPF IPv6 supported OSPF, definitely you have to set up the router ID, otherwise it will not function. So this is the basic configuration of the OSPF, and OSPF is a very stable protocol, and definitely there are some other concepts also, like you can set up the DR BDR designated router and backup designated router also to minimize the LSA flooding. Like all the routers, they are actually exchanging the LSAs using the 224.0.0.5 among themselves. So lot of LSA is being say they actually exchange. So it will cause a lot of LSA flooding. To minimize that, you can elect a router as a DR and BDR, that is like the leader, like the captain, and the vice captain is the BDR, and it will use the 224.0.0.6 multicast address to communicate with the DRBDR in case of any LSA update. They will not share the updates directly with the neighbor routers. So that is also a separate concept on the advanced OSPF. So that is about the basic OSPF, and also you can check the show IP protocols, and you see that the OSPF is indeed running, and you can see the router ID. You can check here that the router ID is 1.2, so it has taken the serial ports IP, and you can see the maximum path 4 means it does the equal cost multipath, equal cost load balancing among the maximum 4 the equal cost paths. It doesn't do the load balancing on the unequal cost path like the EIGRP. That is the difference also. And it's routing for these networks, and it has got the routing information sources, and it has got the AD 110, so distance is 110 by default. So you have got a lot of information, every information of the OSPF routing protocol that is running on your router, and these commands are very vital for your troubleshooting purpose as well. So these are the very essential components of the OSPF routing protocol, and as you see in the enterprise networks today, OSPF routing protocol is a very important protocol because it is the, you can say, the vendor neutral protocol from very beginning. But before, it was the RIP, routing information protocol, and the EIGRP protocol, it was Cisco proprietary. Now the EIGRP, we can definitely understand it is vendor neutral, but for a long time it has been the Cisco proprietary protocol, so that is why it was not so popular. But OSPF from its inception, it is a vendor neutral protocol, and also it is fast, so it is definitely a big choice, a good choice for the network engineers to use this routing protocol for the enterprise networks, not for the ISP backbone. In the ISP backbone, you are having the networks like the BGP and the ISIS, the intermediate system to intermediate system. These protocols, they run. So we have the routing, that is very essential part of our Cisco syllabus, and it covers a lot of, almost say the 20 to 30%, 24 to 30% in the syllabus in Cisco CCNA, and also in the CCNP, the NRC paper. So you learn the static routing as well as the dynamic routing protocol, and OSPF is a major protocol that you see in the CCNA 200301 nowadays, and also in the CCNP level also you have a lot more in the OSPF, like you have the advanced OSPF, the multi-area OSPF. So you have to learn a lot about this OSPF, and you get a special offer that you are getting flat 30% off on any course from the Indian Institute of Cybersecurity when you enroll today. And so you have to fill up the form that is distributed with this session, and the offer valid only till 9 p.m. tonight. So as you are seeing, that is running at the bottom of the screen, so everybody should get this offer right now. So that is about the OSPF, the routing protocol, and definitely we have dived deep into this OSPF, and I have told you every features of the OSPF routing protocol, and I have shown you also the preliminary or the basic configuration of the OSPF. Definitely OSPF is endless, and it has more advanced features like DRBDR, summarization, authentication, IPv6 up to OSPF, that I will definitely tell you later someday. But this is the first thing, this OSPF, that you have to grasp this knowledge in order to climb up the ladder and do the advanced features more. So that is all I have for the OSPF session for today for you, and I hope that it was very helpful for you, and it was very informative for you as well, and you have got a good understanding and knowledge of this OSPF protocol from this webinar, and also you will be able to configure the OSPF protocol in the exam and also in the production environment as a network engineer. It is very important to have a good grasp on these routing protocols like OSPF. So that is about the OSPF protocol that I have, and I thank you all for watching this and joining this webinar once again. I will come with some new advanced topics next time. Till then, keep studying, and bye.